Okay, well, this is as promised. This is the second part of the video, so this will be a much shorter. Okay, but it's important to talk about this. So I also paused it because I wanted to reorganize. I wanted to organize everything into one directory. So I made a directory and dumped everything into it in documents. And here you can see. Here's example HM, right? This is the hypermesh file. This is the one that we use to make the model. So if I double click on this, it'll start hypermesh, right? And you'll see the model that we made just in the previous video. Hopefully. It takes so long. Yep, there we go. We'll just pick that to be obvious, right? Yeah, you see there it is, right? Okay. Now when we went to go solve it, it just created a bunch of stuff from running it. When we went to solve it, it also generated the FEM file. And if we open that up in a text editor, you will see the cards that we talked about in class, right? So here are the grid points. Here are the material cards, the SPC cards. Everything with a $ in front of it is a comment, so it just doesn't mean anything. So Hypermesh will put in these weird things here for its own purpose. You don't really have to look at them. And here's the executive section. So this is the input file. So you can actually run this directly through the command line. You can edit this and whatnot. Okay. All right. Let's close all other tabs. All of this. All right. Excuse me. All right. Now, also it has this H3D file. That is the GUI output file, if you will. If I double click on this, I believe it will open up HyperView. Oh, it brought in it did the fancy HyperView, which I don't know how to use. But anyway, if you open up HyperView, this is the type of file you would open up, the H3D file, okay? All right. Now, it also wrote out some other things because we asked it to. So let's talk about this. I'm going to highlight these 3 files. So you remember we went into there and we had it explicitly write out the displacements, the element forces, and the stresses in an opti file. So those are those text files. So let's look at those. I'm going to just open those up. And here they are. So here's the displacement file. So you can see here that each row is for a different node. So we have node 1 and node 2. And this gives you the 6 degrees of freedom for each node. So the first node, as we expected, all 6 are 0 because it was fixed. And as we would expect here, everything is 0 for the second node except for this last one. This is degree of freedom 6. That's the rotation around the z-axis. And so here's the angular rotation in radians. So we could take this value. This is the twist per unit length, right? So this is the twist for the 10 inches. If I divided by that 10, that would be the rotation per unit length, right? But this is the actual rotation about the z-axis in radians. This would be the displacement in the x direction if there were, in the y, and the z, okay? Now, element forces are nice as well. They show you, for different types of elements, the actual internal forces in the elements. So in this case, we have one element, just rod 1, and so it just puts them here in one line. So you can see the force at the first node, the force at the second node, and the moment. So these are about the element axis. Since it's a CROD element, you can only have an axial force, that's these, or an axial moment, and that's these. So here you can see that the forces, the moments at node 1 and 2, or A and B, are the 1,000 pound-inches that we applied, which is what you'd expect, okay? Again, that's useful for some other cases, all right? And now the last one we want to look at is the stresses, okay? So stresses are a little tough to see, but the first three, oh, I always have to look this up. I should have had this looked up before. I'll post a link to it, but I always forget what's what. But in this case, it's pretty easy to see. This is the maximum shear stress, and you can check that because all the other ones are zero. This is the maximum overall axial. These are the max axial at the first and second node. I believe this is the max shear overall, and this is actually the force. I don't know why I put those in there, but yeah. So for problems where we're asking for the max shear stress, you can look at them here. Now this is the one that actually correctly calculated with TC over J. So this is part of the issue with why we need to look at these in this file. In the post-processor, at least the Hyper-View, it doesn't seem to want to show those values explicitly. It'll put it into the effective von Mises, but not that one, okay? So when you do the homework problems and they ask you for torsion or bending, find the maximum shear stress, the maximum bending stress, you really need to write out the element stresses into an opti file and look at them in a text editor, okay? So we'll do a lot of that, all right? So here it's pretty easy to see. And like I said, I'll put a reference that's a little better to show you what each field does, okay? So this, again, you can look at the displacements, the element forces. We could also look at the reaction forces. I thought I wrote those out. Where are they? The reaction forces. Are they here? Maybe I forgot to write those out. Usually they're like SPC force or something like that. I don't see those. So whatever. Okay. All right. You can tell by the extension. All right. So that's pretty much it. So again, I mean, this is how you go about setting up very simple shell element problems in HyperMesh. Okay. All right. Thanks. We'll stop there.